Hi, welcome to FielDHub. In this video, I'll show you how to create an experiment with a partially replicated design in FielDHub. We can do this in both the FielDHub app and the FielDHub package for R. A partially replicated design is commonly used in early generation field trials, and can be useful if there's insufficient seed quantity or a large number of entries. In a prep design, we split the entries into groups and specify the number of replications for each group respectively. So, if we have 300 entries, we can split them into groups of 100 and 200, and have 2 replications of the first group only. So, we end up with 100 times 2 plus 200 times 1 equals 400 plots for our field. We recommend that you replicate at least 1/3 of the treatments. To begin, I'll show you how to make a prep design in the FielDHub app. First, open an R terminal and install the FielDHub package with install.packages FielDHub. Then, open the FielDHub app with FielDHub: run app, which launches the application. Then, select partially replicated designs from the menu bar. Then, we can set the parameters for the design in the input panel on the left. The first setting is an option to import a list of entries in the form of a CSV file. The format of this file should be 3 columns with the headers entry, name, and reps, with reps containing the number of replications for the treatment in the respective row, as indicated in the pop-up window that appears when you select the option. For this example, we will not upload a list of entries. Next, we have a box to enter the number of entries per rep group, in which we write the number of entries or treatments in each group in a comma-separated list. So, if we have one group of 100 entries and one group of 150 entries, we write 100, 150 in the box. Then, we set the number of replications of each group with the next box, number of rep per group. If we want to have 2 replications of the group with 100 entries, and 1 replication of the group with 150 entries, we write 2, 1. The first group is matched to the first rep per group number, and so on. Some users may want to add checks to their design. If we want to add 4 checks repeated 10 times each in the experiment, we add 1 group of 4 entries with 10 reps, so the inputs are then 100, 150, 4 in the first box, and 2, 1, 10 in the second. In this design, all replicated entries behave the same way as checks. Below this, we have an option to run the experiment over multiple locations with the input number of locations box. We can select which location is displayed with the box next to this, choose location to view. We'll set 2 locations for this experiment. The settings below this are the same as in the other designs, with boxes for plot order layout, seed number to ensure consistent randomizations between sessions, experiment name, starting plot number, and location names. Since we have 2 locations, we can enter a name for the second location as the second entry in a comma-separated list. Once we have entered all the parameters for the design, we can click the Run button. We are then prompted to select the dimensions of the field from an automatically generated list of options based on the number of entries and reps. Once we select the dimensions we want, we click the Randomize button. Then, on the first tab in the Output region, Get Random, we have a text output displaying the parameters of the design and the first 10 rows of the field book. On the next tab, Data Input, we see the list of entries in the experiment, as well as the reps for each entry. If we upload a list of entries, that is displayed here, with our custom names in the name column. We can see here that the 4 checks we added with 10 reps each appear at the top of the table. On the next tab, Randomized Field, we have a graphical layout of the field with dimensions we selected. The field has labeled columns and rows, and each plot contains the number of the entry in it. The replicated entries are colored green, and the unreplicated entries are colored white. Like the other designs, we have buttons to copy this layout to the clipboard and to save the layout as an Excel workbook. Since we set the number of locations to 2, we have a completely different randomization of the entries when we change Choose Location to View to 2. We can see here that treatment 100, for example, is replicated twice here and appears in 2 different places in the other location. The next tab, plot number field shows the plot number of each plot in the field, based on the plot order layout we selected. There are Copy and Excel buttons on this tab as well. The last tab, Field Book, contains all the information about each plot in the experiment, including the treatment in the plot, the column and row of the plot, and the location the plot is in, which will vary if there are multiple named locations. We can save the field book as a CSV file with the Save Experiment button at the bottom of the input panel. Like the other designs, we can also simulate a variable over the field and display a heat map based on this with the Simulate button. Like all the other designs, we can create an identical experiment using the FielDHub package for R. First, load the package with library FielDHub. We can use the partially replicated function to define the design. We'll save it to an object called preps. The arguments for the design are as follows. N rows is the number of rows in the field, N cols is the number of columns, L is the number of locations, and rep gens and rep units are both integer vectors that contain the number of entries in each group and the replicates of each group, respectively. So, if we want to create an identical experiment, rep gens equals 100, 150, 4, and rep units equals 2, 1, 10. We also have arguments for customization of the experiment, like plot number for starting plot number, experiment name for experiment name, and location names for location names. We can also set a seed number with a seed argument. Once we have set up the partially replicated function the way we want, hit enter. Then, we can use the print function to display the same text output as appears on the Get Random tab in the app, with a description of the design parameters and the first 10 rows of the field book. The preps object we created is a list, so we can use the $sign operator to view just the field book with preps $fieldbook. We'll save this to an object called FB, and we can use the view function to display the field book in the terminal. We can also view the layout of the field, like what is displayed in the randomized field tab in the app, with the plot function.